Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today I will talk about wastewater treatment. We 19 students from Department of Chemistry, University of Karachi have collected this information to represent you the working of wastewater treatment plant. Before starting, I, on behalf of my whole team, want to thank Dr. Sadaf Iqbal for providing us this opportunity to learn such an informative and useful technology. We have learned a lot from it. The entire presentation is the result of collaboration of these students. Now moving forward to the introduction. What is wastewater? Wastewater is used water composed of human waste, food scraps, oils, soaps and chemicals. Now, types of wastewater. There are basically three types of wastewater: black water, grey water and yellow water. Now, sources of wastewater. Sewage water, which is basically composed of the waste from domestic activities, and the other is non-sewage, which is commercial waste of industries. Now moving towards effects of wastewater. Wastewater causes contamination and destruction of natural habitats. Now, what is wastewater treatment plant? It is a process that makes water suitable for specific use which has no longer suitable. And finally, types of wastewater treatment plants. Effluent treatment plant, it is used by chemical and pharmaceutical industries. Sewage treatment plant, it is used in domestic water treatments. And the other one is common and combined effluent treatment plant. It is used in small scale industries. And finally, the last one is activated sludge plant. This is another method used in sewage water treatment. Moving forward to the stages of wastewater treatment plant. Stage 1, primary treatment, which means physical treatment. Stage 2, secondary treatment, which includes biological treatment. And the third one, stage 3, which is tertiary treatment, includes chemical treatment. Let's talk about the primary treatment of wastewater treatment plant in detail. Primary treatment is done by pouring the wastewater into big tanks for solid matter to settle at surface of tank. After settling, the sludge, the solid waste that settles at the surface of the tank, is removed by large scrappers and is pushed to the center of cylindrical tank and later pumped out of tanks for further treatment, which is basically outlet to the secondary treatment. After primary treatment, now we are talking about secondary treatment. In this step, seed sludge is added to wastewater, ensure that it is broken down. This addition of sludge is done in aeration tank in which air is pumped. The growth of bacteria and other microorganisms that consumes the remaining organic material. This process leads to the production of large particles that settles down at the bottom of huge tank. Wastewater passes through these tanks for a period of 3 to 6 hours. Now here is the last stage, which is tertiary stage or tertiary treatment, in which we can remove up to 99% of impurities from the wastewater and which produces effluent water quantity. Actually, this process a bit expensive as it requires special and high-tech equipments and well-trained and highly skilled staff. Now moving forward towards the steps of wastewater treatment plant, in which includes screening, grit removal, primary settling, aeration, secondary settling, filtration, disinfection and oxygen uptake. Yes, this is the pictorial representation of basic wastewater treatment plant. Now let's move on step by step working of wastewater treatment plant. Step 1. Bar screening. Removal of large items from the influent or to prevent damage to facilities, pumps, valves and other equipment. Step 2. Grit removal. Removal of grit by flowing the influent over through a grit chamber. Step 3. Primary clarifier, in which initial separation of solid organic matter from wastewater. Step 4. Aeration. The primary function of the aeration tank is to pump oxygen into the tank to encourage the breakdown of any organic material like the growth of bacteria, as well as ensure there is enough time for the organic material to be broken down. Step 5. Secondary clarifier. In this step, wastewater is pumped into a secondary clarifier to allow any remaining organic sediment to settle out of treated water flow. Step 6. Chlorination, which is also known as disinfection. In this step, chlorine is added to kill any remaining bacteria in the contact chamber. Step 7. Water analysis and testing. In this step, we have checked proper pH level, concentrations of ammonia, nitrates, phosphates, and dissolved oxygen, as these parameters are critical to the plant's performance. Step 8. Effluent disposal. In this step, after meeting all permit specification, clean water is reintroduced into the environment and testing is done to make sure the effluent leaving the plant meets permit specification. After the step-by-step working of wastewater treatment plant, now moving forward to the wastewater recovery methods, which includes induced gas flotation, ion exchange water treatment, media filter, distillation, Imhoff tank, chemical treatment, biological treatment, and sludge treatment. Here we will discuss induced gas flotation in detail. Induced gas flotation is a water treatment process that clarifies wastewaters or other waters by the removal of suspended matter such as oils or solids. That is achieved by injecting gas. Induced gas flotation is very widely used in treating the industrial wastewater effluents that includes oil refineries, petrochemical and chemical plants, natural gas processing plant. Process description. The suspended matter to float to the surface and from a froth layer which is then removed. The feed water to the IGF float tank is often closed with a coagulant such as ferric chloride or ammonium sulfate. Design parameters which enhance the efficiency. Some IGF units designs utilize parallel plate packing material to provide more separation surface and therefore to enhance the separation efficiency of the unit. Moving forward to the next method, which is ion exchange wastewater treatment. In this process, purification of aqueous solution using solid polymeric ion exchange resin. Now discussed in detail. Yes, what is ion exchange? Process of purification of aqueous solution. More precisely, the term encompasses a large variety of process where ions are exchanged between two electrolytes, aside from its use to purify drinking water. When we talking about application of ion exchange method, The technique is widely applied for purification and separation of a variety of industrially and medicinally important chemicals. Third point is process description, which includes water treatment method where one or more undesirable ionic contaminants are removed from water by exchange with another non-objectable or less objectable ionic substance. For example, water softening. Exchange is also efficient in removing toxic metals from water. The next method is media filter. As you can see, this is the pictorial representation of media filter plant. You can see this white tube structure. These are the media filters in the industry. Now talk about the construction of media filter. A media filter is a type of filter that uses a bed of sand, peat, shredded tires, foam, crushed glass, geotextile fabric, anthracite, crushed granite or other material. Now moving forward to the uses or application of media filter. Media filter is used for purification of drinking water, swimming pools, aquaculture, irrigation, stormwater management, oil and gas operation and other applications. Now talk about the efficiency of media filter. Media filter treatment removes more than 90% of suspended solids. Another method is Imhoff treatment. Let's talk about Imhoff. Now, what is Imhoff treatment? Imhoff treatment is a primary treatment technology for raw wastewater designed for solid liquid separation and digestion of the settled sludge. Uses and applications of Imhoff treatment. It is used by small communities and due to the underground construction, land is very limited. Unit design. It is consist of a V-shaped settling compartment above a tapering sludge digestion chamber with gas vents in the digestion chamber. The settled solids are anaerobically digested, generating big biogas. Efficiency. Solid reduction of 50 to 70%, COD reduction of 25 to 50%. Investment. Let's talk about investment. Investment cost are low and operation and maintenance simple. This is the schematic of an Imhoff tank. As you can see, this is a V-shaped tank and the sludge is settled down at the bottom. This is the sludge outlet pipe or sludge outlet, and this is the cross section of Imhoff tank, and this is the planar view. Moving forward to the next method, which is distillation. Distillation for home treatment. Home water treatment should be considered only a temporary solution. Distillation effectively removes or inorganic compounds such as metals, lead, nitrate, and other noxious particles such as iron and hardness from a contaminated water supply. The boiling process also kills microorganisms such as bacteria and some viruses. Distillation removes oxygen and some trace metals from water. For this reason, some people claim distilled water tastes flat. Unit distillation. Unit distillation consists of boiling chamber in which water enters, is heated and vaporized. Number 2, condensing chamber, which includes condensing coils or where the water is cooled and converted back to liquid. Storage chamber, which is used for stored purified water. Common methods for distillation. There are two common methods for distillation. One is solar distillation and the other is multi-stage distillation. Distillation, it does not remove all chemicals but removes some soluble minerals like calcium, magnesium, phosphorus, etc. Some dangerous heavy metals like lead, mercury, arsenic, etc. Apart from advantages, there are some disadvantages of distillation like energy, slow output, and cost. Disadvantages of distillation are the energy needs of the unit, the cost, and the slow output. There is also the concern that since distilling water removes all minerals, drinking distilled water may leach out minerals such as calcium, magnesium, and fluoride from the body. Next method is chemical treatment. Chemical wastewater treatment plant. In chemical wastewater treatment plant, removal of pollutants with the help of chemistry, treating these metals chemically by adding either calcium hydroxide or sodium hydroxide helps from insoluble metal hydroxide that can precipitate out of the solution. Chemical wastewater treatment standard process typically include precipitation, coagulation, and flocculation, ion exchange in disinfection. Coagulation and flocculation, ion exchange in disinfection are already discussed in this presentation. After chemical, now talk about the biological treatment system. Biological treatment is used for the easily biodegradable elements. For example, carbohydrates, polysaccharides, starch, sugar, proteins, edible fats, and smaller aromatic compounds that are easy for bacteria to break down and digest. Moving forward to the next method, which is sludge treatment. In the sludge treatment, produced the sludges that produced and collected during the primary and secondary treatment process requires concentration and thickening to enable further processing. It is put into thickening tanks and that allows it to settle down and then separated from water. Let's move on our last topic, which is wastewater treatment in the world. In this topic, disposal or reuse occurs after treatment. It must be considered first since disposal or reuse are the objective of wastewater treatment. Disposal or reuse options are the basis for the treatment decisions. Acceptable impurity concentration may vary with the type of use or location of disposal. Let's move on the wastewater treatment plant in China. In China, we have discussed wetlands, water recycling, working, and industrial treatment. China wastewater treatment industry broadly covered the treatment of influent sewage treatment and water recycling. In 2015, around 74 billion tons of wastewater was discharged by China's population. Few factories do so consistently because of the high cost involved. Municipal wastewater treatment is typically undertaken by local government industrial wastewater treatment done in the factory. Construction. Constructed wetlands can be defined as man-made engineered designed area for the purpose of treatment of wastewater by improving the physical and chemical and biological environment that can occur in natural wetlands ecosystem. Wetlands, the combination of two or more types of constructed wetland system called hybrid construction wetland system. Construction wetland system. Selection of construction wetland system depends mainly on the target element for treatment. Constructed wetland are mechanically simple but biologically complex system. Move on the industrial treatment. From the last several years, construct wetlands are becoming a popular alternative option for the wastewater treatment because of its low energy development and maintenance cost, easy operation, high pollutants removal efficiency. Let's move on our next plant, which is wastewater treatment plant in Australia. We have discussed in this topic system of treatment, renewable energy importance, and water recycling. A wastewater treatment plant in facility in which a combination of various process, physical, chemical, and biological are used to treat industrial wastewater and remove pollutants. Australia operates over 100 wastewater treatment plants across the state. If we talk about system of treatment, so there are three modern lagoons system at the Western treatment plant. A modern lagoon is typically made up of 10 large ponds, each of which can hold around 600 million liters of water. Sewage flows slowly through their ponds are allowing bacteria to break down the organic material. If we talk about water recycling, a water recycling disinfection plant was built at the Western treatment plant in 2004. This plant treats classic recycled water to class A standard, which means this water is suitable for a greater number of uses. If we talk about importance of wastewater treatment plant in Australia, the Western treatment plant is one of Australia's best known sites for recreational birding, with about 270 species of bird recorded there. Let's move on the wastewater treatment plant working in Japan. We have discussed overview, construction and working, pollution control, and CSS control. Let's discuss the overview. Sewage work in Japan was developed rapidly since 1960. Regional divide is one of the distinguishing characteristics of sewage works in Japan. Japan has built a total of 460,000 kilometers of sewer lines and 2200 treatment plants for public wastewater service. There are so many wastewater treatment and water treatment companies in Japan. Let's talk about construction and working asset management. Japan has built a total of 460,000 kilometers of sewer lines and 2200 treatment plants for public wastewater service. The failed sewer cause around 4,000 cases sinkholes annually. To improve this situation, asset management have been discussed and implemented. In 2015, the sewerage law was amended to ensure safety and sustainability of wastewater service. Population control. Rivers are much cleaner than they used to be in the 70s and 80s due to expansion of wastewater service up to 80% of population. However, the problem in stagnant coastal and freshwater bodies remain a challenge. The population affects fisheries, ecosystems, and recreational use and drinking water treatment. Let's talk about CSS control. CSS control is combined sewer system. Sewer around 25% of population and 13% of a total of 1430 municipal with wastewater service in Japan. And CSS are designed to carry both sanitary wastewater and storm water in the same pipeline. Let's summarize our presentation. What we have studied till now is what is wastewater, stages of treatment plant, steps of treatment, methods of treatment, and last, treatment in different countries, China, Australia, and Japan. That's all, and thank you so much for watching.